Good evening, everyone. I warmly welcome you all to the 52nd Study Circle organized by Universal Briefing. Before we begin today's technical session and scholarly discussion, I would like to extend a heartfelt welcome to our sir, Professor Burdwan Bhattacharya, President of Universal Briefing, and our chairman, Dr. Ovik Roy, librarian of Dirojio Memorial College, and our convener, Mr. Abhijit Noskor, librarian of PM Sri KV Bagafa, South Tripura. We are truly honored to have with us two distinguished personalities in the field of library and information science. Our esteemed speaker, Dr. Rajesh Das, Assistant Professor, DLISC, University of Burdwan, and our President, Dr. Sibsankar Jana, Professor, DLISC, University of Kalyani. Sir, we extend our sincere and heartfelt welcome to you. Today's topic, linked open data and the OpenRefine tool, promises to be both insightful and engaging. I encourage all participants to actively take part in the session. Please feel free to share your questions through our YouTube channel, the Google Meet chat, or you may ask them directly after the speaker session. Now, it's my pleasure to invite our anchor for the session, Srimati Rupali Rupasmita Pradhan. She is a promising scholar who is currently pursuing her PhD at Jadavpur University. With that, I hand over the session to you. Thank you once again. I hope you all have a wonderful and enriching session. Over to you, Rupali.
Thank you, ma'am. A very good evening to everyone. We are now going to start our 52 Study Circle of Universal Briefing. This evening session will be presided by Dr. Sibsankar Jana, Professor, Department of Library and Information Science, University of Kalyani. Our speaker for today's study circle is Dr. Rajesh Das, Assistant Professor, Department of Library and Information Science, the University of Burdwan. I now take a moment to introduce the president for today's session, Professor Sibsankar Jana. Dr. Jana is a professor in the Department of Library and Information Science at University of Kalyani. He has passed his Master in Library and Information Science from Jadavpur University. Later, he has completed postgraduate diploma in Digital Library Management, and he has also completed his PhD from Jadavpur University. Earlier, he passed MSc in Geology from Calcutta University. He has written 5 books and near about 125 research articles published in reputed journal, conference proceeding, book chapters, and book chapter. He has also delivered invite lecture and chair session in different seminar and conference. His domain of interest mainly are knowledge organization, ontology, scientific, digital resources management, and e-resources management. Now, I would like to request sir to take charge of this session. Over to you, sir.
Thank you. Am I audible?
Yes, sir. Yes.
Okay. Thank you. I am very happy to be present here and thank to our sir, Professor Burdwan Bhattacharya sir, and the convener of this 52nd Study Circle of Universal Briefing, also the chairman of this study circle. Today we have with us Dr. Rajesh Das. He is now in the Department of Library and Information Science, Burdwan University. He is a good researcher and he has also completed ML Digital Library Management from Jadavpur University. So he was my basically the classmate then, and he is now working on digital library, link open data, OpenRefine, and ontology. So I would like to request Rajesh Das to deliver his lecture on the link open data and OpenRefine tool. Over to you, Dr. Das.
Thank you, Professor Sibsankar Jana, sir. Am I audible?
Yes, audible.
Yes,
Audible.
sir.
Yes.
Thank you. First of all, I sincerely express my gratitude and thanks to Professor Udayan Bhattacharya, President of Universal Briefing, for inviting me in 52 circle of Universal Briefing as a resource person. I also express my gratitude and thanks to the all members of the Universal Briefing, chairperson, convener, anchor, and thank all my fellow participants in the study circle. And now, with kind permission of President, I start my presentation.
Okay, carry on.
Let me share first. My screen is visible.
Okay. Yes. Now it is visible.
Today, I'm going to.
You can go through the full slide mode, slideshow mode.
Now is okay?
Okay. Now it is okay.
Today, I'm going to present my topic, link open data and OpenRefine tool. At present, we are living in digital age. Not only digital, we are day-to-day habituated with AI, artificial intelligence, machine learning, data science, in every domain. So libraries and information science is not exceptional. Okay. We are trying to integrate different tools and techniques in our domain for better service, better technology, and better web development. So let's first know that what is link open data. Then link open data basically is a component of semantic web. So what is semantic web? All we know that semantic web is a web 3.0 platform. Okay. It contains different advanced technology, web services, models for integrate for data extraction, data wrangle, and data refinement. Okay. So why link open data? Okay. At present day, we are concentrating about data, every data, not information, not data. So web of data documents goes to web of data of things. The piece of information, data means piece of information. We're dealing piece of information, things, and raw data also. Or what deconstruct web pages, web semantics, like person, place, event, create. It allows computer to understand and process data on web. Computer, when machine could understand and machine can process on the web. Okay. So it is very convenient that the machine, the human part, is to when we write a program should what to do, how to do, everything is to write. But in this technology, semantic web technology, computer may constant the part of that area that machine can understand, machine can process the data. Okay. Then what is linking? The concept introduced in Burnwan in 2006. Okay, it is the father of semantic web data and linked data technology. It is recommended a best practice for exposing, sharing, and connecting data, information, and knowledge. Knowledge is structured data on web. Okay. Link open data is basically nothing. It means structured data. Structure is the structure that is the schema, metadata schema, and structure with links, everything. Key technologies, URI, HTTP, and RDF. It includes URI. URI means Uniform Resource Identifier, not URL. Okay, it's a resource identifier. That means every data has its own identifier. Okay, and HTTP technology, we know that web technology includes several technology like FTP technology, HTTP technology, and semantic web link data that that always works on HTTP technology. And RDF. RDF is basically resource description framework. It is a model. Okay, the data could be modeled by RDF. Link data versus semantic web, like pieces versus whole. Okay, it is the main component of the semantic. Then comes the open data. Open data is nothing. The data can be freely used and distributed by anyone. It is called open data. No licenses there, no restriction. Anyone can download it freely and modify the data and distribute it to other platform or in a form of data set, database of web pages also. The open data does not equal linked data. Open data can be made available to everyone without links to other data. At the same time, data can be linked. Data can be linked without being freely available for use and distribution.
Just a minute, Rajesh, just a minute. Rajesh,
Okay.
Is there any audio problem? Listener, please. Is there any audio problem?
No, voice is
No.
somehow cracking, but it is we can listen it. Okay.
Audible.
No issue.
Acha. Oh,
Audible.
voice is cracking. Yes.
Yes, sir.
I think he is under a fan.
Yes.
So voice is buffering. Okay. Carry on.
Now clear? I switch on the fan.
Yes, clear. Yes.
Now clear.
Okay, thank you. And so linked data is a powerful blended. Link open data is a powerful blended of linked data and open data. Both linked and uses open sources. Technically, linked data and linked open data are same. It builds upon standard web technologies such as I said that HTTP, RDF, and URL. But rather than using them to serve web pages for human readers, it extends then using them to serve web pages for human readers. It extends them to share information in a way that can be read automatically by computer. Main objective to transform web of documents to web of data of things, to provide more links for more information of a thing, to provide URI links for structured data, to produce data on web and LOD in different ways, that is data sets, SPARQL interface. That means link LOD can available in different ways. we can avail as a data set, and we can access from SPARQL interface. SPARQL interface is nothing but a like MySQL interface, and it can access the LOD. MySQL, we know that MySQL can access RDMS, the Relational Database Management System, but SPARQL can access the LOD. Okay. Consume LOD in digital library environment to enrich data on web with integration of standard linked dataset or external data sources. Okay, we can enrich our dataset by integration with external dataset. We'll show in demonstration section. Okay. To share and connect LOD as dataset or SPARQL service for using the other organisers. The four design principle of linked open data. Okay. Use URIs as name of things. Always we use URI as name of things. Use HTTP URI so that people can look up those names. When someone looks up URI, provide useful information using standards like RDF or SPARQL. It includes links to other URIs so that can discover more things. That is external resources. Okay, we can integrate external resources with links. 5-star schema. LOD is 5-star schema. It's also recommended by Burnwan World Wide Web 3 Consortium. Available on the web, but with an open license to be opened. Available as machine-readable structured data, the Excel instead of image scan of a table. Because Excel format, we know that Excel format like as a database or RDBS tabular format, row column in section, we can every row as a record, every column as a facet or field or parameter. S2 plus non-proprietary format. Always use non-proprietary format like CSV instead of Excel. All the above plus we use standard from W3C RDF and SPARQL to identify things so that people can point at your stuff. All the above plus link your data to other people's data to provide context. Link your data, provide URI within other people's data. That we could map the two data with URI to find out to provide a specific concept. And now come RDF. To know that RDF, Resource Description Framework, is a syntax for representing data and resources. It is metadata model, not format. RDF always is metadata format. The model consists of 3 sections: subject, predicate, object. A resource which identified with the URI. Predicate. Predicate is nothing property. Okay. Predicate is a property of the statement. A URI identified. It also must be URI. Identify use specification of the relationship. In this section, we put the namespace of the metadata. Okay, namespace of the metadata schema. We use specific metadata schema. Object, a resource or literal to which the subject is related. Okay, it can be URI or it can be string, name, or literal. Okay, this is the story of RDF. We can see the picture. That is the so just see the example. The Brussels is the capital of Belgium. We use Brussels with its full URI. Okay, not Brussels. http://example.org/press Brussels is the capital of Belgium. And Belgium, it is the object. Okay, its object is may be named literal, or in the after that we can see the maybe it also defined with URI. That is example.org/press/Belgium. Okay, predicate is the capital. It is also with URI. When we use the specific metadata schema or ontology, we can put the whole part of the predicate. Now, RDF can be serialized in the following format like RDF XML, RDF JSON, Turtle format. Turtle is very popular format. N-triple also popular format, and entry notation. Okay. Most of we use XML, RDF XML, and Turtle format for data extraction, data transformation. And nowadays, JSON LD or JSON RDF is also becomes popular for the data imported export. Okay, it is an example of RDF. I will show the in demonstration section. So it is in Turtle format. SPARQL is nothing but SPARQL protocol and RDF query language. It is a standard language to query graph data represented as RDF tuples. Basically, it can access LOD like MySQL statement. A semantic query language for databases datasets, able to retrieve and manipulate data stored in RDF tuples. We can directly edit, modify, and change in RDF section. Okay, through this query. This is an example of SPARQL. And left side the SPARQL interface, which is a dbpdf word you can see, and row taken and query, and the result that right section. This is SPARQL. Okay, use of SPARQL. And some link open data implementation and resources. We know that Wikidata is very popular. It is a free and open knowledge base that can be read and edited by both. You can read and edit it by both humans and machine under Wikimedia project and free license. Acts as central storage for the structured data of all Wiki families, like Wikimedia, sister project, include Wikipedia, Wikibooks, Wikinews, so many. Okay. This is Wikidata, and dbpdata is popular resources. It also extracts in from Wikidata, Wikipedia under the Creative Commons attribution. They are like 3.0 licenses and the GNU free documentation. And we can see the huge data, millions of things, persons, place, creative works, organizations, species, all this type of data content by dbpdf. Okay. How we can access type, downloading data set or SPARQL in endpoint. Okay. European Union also is a project of European project archive, library, museum, and share culture for enjoying education and research under European Union. Okay. It also search and browse interface and SPARQL interface. European is a very popular project, and those people who are working with semantic web link open data, they always access European project. And now in library science domain, DPLA, Digital Public Library of America, it is within American libraries, archive, museum, and other cultural heritage, photographs, books, maps, so many types of resources they hold. And with its main feature is with its integration with external resources. You can access and download the resources in RDF model. Okay. Another is ShareVD, is a collaborative project promoted by Kalyani Library, provided bibliographic and authority data. Okay, it provided bibliographic and authority data of 20 members libraries in US and Canada. It mark format to RDF model format they converted and became vocabulary and other ontologies through process of entity identification. And this is the screenshot of CRBD library and other popular resources. Open library, we know that it's begin 2007. Internet archiving containing over 20 million edition report online. We can access and see the catalog of the catalog of resources. Okay, OCLC WorldCat is a link open data platform, and you can download the bibliographic information in like this format, like RDF, XML, Turtle, JSON, LD, and TPL format from OCLC WorldCat. Okay, and now the popular vocabulary, LOC link data services. It is a LOC project, fast faceted application of subject terminology. It is also the project of geonames, is a project for geographical location. Here we know that virtual internet authority for authority, person name, organization name. WorldCat identifies, it is also the resources for the parks authority and authority. Okay, internal IS, and we know the internal standard name identity, the personal name authority, and ORCID, we know the ORCID, open researcher and contributor I. It is a popular vocabulary. These are. And now ontology of RDF vocabulary. That is DCMI, metadata term. Okay. DC metadata term. It is a doubling for extended version of DC. Extended version of friend of a friend. Friend of a friend. It is a person. This vocabulary is called person. How we describe the person with its related facets. The MADS RDF, which is the LOC project. Mods RDF, schema.org vocabulary. It is a beautiful vocabulary for describing creative works, books, and other the resources. Okay. And now I will demonstrate two things: producing LOD using OpenRefine tool. How we can produce LOD by using OpenRefine tool. And another part, use of AI extension for metadata extraction. Okay, AI. Basically, the AI extension comes not very early. Recent, it integrated with OpenRefine tool, and it is a beautiful feature for LLM. Okay, we can directly access and extract from any LLM. Okay, data in natural language, not machine language. Just give your language. The machine can extract the data in your language, what you want, in which language. Okay, so let's start the demonstration. The screen is visible.
Yes, sir.
Okay. This is the OpenRefine site. Okay, and it is a download section. The latest version is VR 3.10. Okay, but latest version, I recommend always use stable version. Okay, don't try latest version. Always try stable version. And you can old version or stable version you can access, but you can download, go to their archive section. And this is the extension. Okay, extension means OpenRefine is a plugin software for specific um, specific manipulation of data or transformation. Different type of extension. I use two extensions. One is AI extension and another is RDF extension. Like RDF, this is RDF extension. So just install, download the tar.dz in Linux platform in Windows.exe software and extract with the folder and just go to the, I use the here for RDF extension 3.7.2 and just type the /refine and run, and now we can localhost colon 3333 is the port number of the OpenRefine. OpenRefine is run in this port. Okay. Every web service has different. Okay. By default, it has a port. You can change port in configuration file. Please come in. Create a project. Browse. I have a CSV file of the records of book. This is just a small CSV file containing 20 records. Okay. And bibliographic information. You can see. And the column is accession number, title, author ID, author, publisher, place, publication place, and year of publication. These are parameters or fields of the CSV file. And now we make it LOD. How? Before making LOD, we will integrate every, not the primary, the important column from external resources. Okay. So that is called reconciliation. If we go to OpenRefine documentation, you can reconcile in section, reconciling from others, from external source. Okay, and for the reconciliation, the many programmer or developer build reconciliation service application. Okay, so there are popular. I use the application. One is LOC reconcile, and another is sorry, another is conciliate. Another is conciliate. Okay, I used for this purpose. Okay. So first, I had to start the service of those apps before reconcile the title, author, publisher, place, service. So let's start separate window. the how to the reconciliator, LOC reconciliator and conciliator, how to install, how to get the file, all those mentioned in that GitHub project. Okay, don't worry, you can go GitHub project page like this. Here is the all program, all installation procedure and install how we could use all the mentioned here. Don't ask. Just start.
Rajesh, background noise is there. Background noise.
I already switched off the fan. Now
No.
it is okay. Still now?
I think no. It's still someone is talking. I think.
Oh, 1 minute.
এত কিসের আওয়াজ হচ্ছে ক্যাচ কুচ ক্যাচ
আরে বাবা বাড়িতে আছে আওয়াজ করবে না বাড়ির লোক শান্ত হয়ে বসে থাকবে
আরে দরজাটা তো বন্ধ করে দেবে একটা ছেলে একটা বলছে কথা বোঝা যাচ্ছে না এটা হয় নাকি একটা টেকনিক্যাল জিনিস ওকে ওকে হ্যাঁ নাও ওকে
It is a service and another service LOC reconciliation. Just I start both service. Okay. Now let's start for reconciliation. First, we will reconcile from external sources of the title. Okay. Let's start. Before starting, we make a redundant column. Same column. Okay. We don't touch the original column. This is the Grail interface. Title 2 column is same column. Title 2 is the redundant of title. Now we reconcile this column. Okay. Reconcile, start reconcile. We have the reconciliation resources. Okay. The title from Open Library. Let is working. We found the facet from Open Library book. It is the only facet, and now start reconciling. We can see the progress of the reconciliation process. 50% complete. It is a small data set, 20 records, so not take more time. Mhm. The first title, Introduction to Information Science. We can see introduction in 3 times. Okay, 3. Retrieve 3 records. Actually, we see the every record and its authors publishing every information. Then we select. But less time, just we assume that it is the right title. Foundation of library, like I choose it. The organization from it retrieve 3 records, but it not match. If not match, that leave it. Cataloging and classification, just take first. Information storage retrieval, library management, it also not match. 5 laws of library science, digital library, it also not match. Knowledge organization, not match. Metadata, matched. Introduction to algorithm, computer networks, operating system concept. Just clicking, select. Okay. Artificial intelligence, modern approach. Artificial intelligence, modern approach. Not match. Clean code. Okay. The pragmatic programmer. Okay. Database system concept. Computer organization and design. Deep learning. And last one is Python crash course. Okay. We reconcile from where? From OpenRefine. Now we can put the URI in another column. Just add column of based on this column. Okay, and we can open library URI. Okay, just we can take the only URI. In get space this. Let's exclude this one. And we can see the preview. Okay, this preview with every record with its URI from Open Library. Just OK. And has created the column. Any link we can click and go to the particular book in Open Library website. We can see. I think Open Library server is down. They're not accessible. Let's see, but this is the URI of the particular book from we retrieve all URI from Open Library. Okay, now we can delete the reconciled column. Okay, so title has URI from external resources, that is Open Library. Then author, we can reconcile author, edit column, based on this column, another author 2. We don't touch the original column, just create a redundant column for the reconciliation first. And reconcile from via. Here we can found three facets: person, expression, what. We have already selected person, start reconciliation. %55%, and we got David Burden. This is the match. Is David Burden match found? Richard A. Rubin, Richard A. Rubin, Arlena G. Taylor, J. H. Bowman, Robert. I think it will be S.R. Ranganathan, William Swan, Richard Smith, Thomas H. Coleman, Andrew S. Tannenbaum, Robert Joseph, Robert is not found, just leave, Andy Hunt, David Patterson, and fellow Patterson, Eric Matthew, last. And similar way, we will fetch the I have already the statement. Replace the via base URL. Okay, and we can see the preview and just okay. Now we can check David Bowden. Okay, we go to the particular page. Okay, we have resources. Okay, and then we should delete the reconciled column. Now publisher. Publisher reconciliation form. Found the publisher, Facet Publishing, Live Unlimited, Facet Publishing. Just select. As oil in John Oil, I think John Oil. Okay. Asia Publishing House, Madras Library Association. Just click and select. MIT means Massachusetts Institute of Technology, Kinjar Bharla, Ala Edition, MIT, Pearson. Pearson is Prentice is the mother of Pearson. John Wiley, Prentice, Morgan. Okay, publisher is created, and now we paste the it also retrieved from VR. So we have the syntax. Just see the preview, and preview is okay. Then, publisher column name should be fine. Publisher URL. Okay, we got the publisher URI from VIAP authority. Then remove this column. And now space place. It is also we can redundant column place to value is the same and reconcile Wikidata. Okay. Wikidata contains the place, records, resources. So try Wikidata, and we found the city. Which is we found the that is London. Santa Barbara, MB, Berlin. Match or identical cell, not only this cell, all identical cell. One place may occur in different records. So the place has done. We can create a column. This is base URI. Name URI. Okay. Base URI we define and just put the tail recon match. These are the command, basically command of Grail expression, and we found the all URIs. And now then Wikidata London against the URI. Let's check. Go to that directly. Okay, our reconciliation with URI process is okay. Let's delete the reconciled column. And last one is subject. We then create subject 2 for the purpose of sub 2 for the purpose of reconciliation and reconcile LCSH. Okay, LCSH subject. And not found reconciliation. Let's try. fetching at present the reconciliation value. Person not match Wikipedia open library. Subject. This is perfect, but presently it is not okay. If we get a facet of subject from open library, then we should go the reconcile with open library.
Better you take from LC. LOC.
No, it works, but sometimes it does not
the
work.
server is down. Yeah.
Problem. Based on LCSH URI. And the expression will this is the base URL. Things should define in whole basic base URL. Okay. Let's try library information science. Let's check one thing. Library information science. Now delete the column, reconciled column. Okay. As we possible, we integrated the external resources in our dataset, like title, author, place, and subject, okay, publisher. Some information, some some found not met. Like this three number three, the organization of information not found from OpenRefine. So this is null. Okay, we can fill up. This is open library. This type of statement for non-empty. We can see the number three is null. So So the appear of the URI like this, okay, /n, okay, and also in any of the author 2 is these are the two null values. So URI like this NA. Almost we have prepared our CSV data set. Now we will go for LOT producing step. Okay. The extension, we can see the RDF extension. It is the main extension for transform the text data to CSV file to RDF model. Okay. We start edit skeleton. By default, it appears. The base URI actually, actually, when we access LOD, it says base URL we can see. So we put our own base URI like www.lod.org/. Okay, it is the base URI. We can define. The LOD is presented in tuple form, RDF tuple, subject, predicate, object. We can see the three columns, row index, this is for subject, property for predicate, and cell, that is literal, or it may be, we can define URI. Okay. So first, our data sheet, we have accession number. First, row index primary, that means subject, we can define accession is a row URI. Accession number URI. Let's preview. Preview like this type of we can access. We can get. Okay. Property. This is subject property. Accession has title. Before we use a property, we import several properties. By default, we can see RDF owl RDF is 4 is the four properties are here. We import like DC property, that is metadata schema. DC term, and another is schema. We use it. We will use. You can import other metadata schema like mads RDF, mods RDF. Several metadata are available. How you make and how you integrate the property in your resources, that solely depend on you. Okay. Now property. One thing, RDF, OWL, RDF page, DC term, these are general ontology or general RDF metadata schema. It's used for all types of e-resources or any web data. Okay. And schema is the domain specific, that is creative work basically, that it includes or also library for domain properties. Okay. This property DC, sorry, DC title. This through title text. One is complete. Okay, accession number has a title, that is C. And this, we keep the same subject and add the another property, that is our same as. Sorry. Okay, same as what? Same as open library URL. We put this. Okay. So this is the subject, predicate, object, and this is the subject, predicate, and object. Another, we can use another low index like author ID. Is always define URI, preview, also set the base URI preview. We can see the preview. Okay. 1 minute. Just add property, that is predicate, schema, author. It is the property, and author name, just text. Okay. Then we made the subject, predicate, object. Then another property, our same as GF URL. This related with author. Okay. Then we create another root node, that is title. Title, don't we allow text, we allow URI. So we do something. Okay. We can replace the all spaces by underscores. So it looks like say perfect URI. URI does not allow any spaces. Okay. Done. Then title has has schema author. Okay, we do it reverse. Okay, author. Then another title has publisher. Title has publisher. We put the name of the publisher. Author, publisher, yes. Yeah, what is the publisher? Okay, we delete it. Okay, no problem. We put the place text. Okay, we create another place URI. Okay, place URI schema place as place and it is a place of publication. And another is subject. Title also has so we put a subject BC subject and subject name. In reverse way, we can create subject URI that is LC HURI our same as. Okay. Relative subject. It is a small skeleton that I maintain the subject predicate object. And primary node is always primary, then the left side column is always subject, middle is the property that is predicate, and right is the object that is name literal or URI. So this way I develop this. Okay. And now in preview section we got the RDF file. Okay. Save and okay. And when we export RDF as a RDF Excel format, we downloaded .rdf file browser. So we have made the dataset CSV file to RDF file, and here we can see the subject, predicate, object format, all information. Not only this format, we another format we can export in turtle format. In turtle format, we can see this way. There are many formats. OpenRefine allow RDF XML and turtle format. We can see the in RDF format. That is URI. Okay. this is title, predicate, this is subject, this is predicate, and this is object. Okay, and this also predicate mean property, and this is object. This object is URI. Okay, so in this way, every data had got their own links. I put a link, valid link, and make a extreme and syntactically correct dataset. Okay, now we can put this dataset on Wikidata or any SPARQL server. Uh, this is a small dataset, 20 records, but we can create 2 million, 3 million, 10 billion. What we can get in our library, we can produce in our mark data into RDF dataset, RDF triple dataset, and provide provide better service and put in the external server, SPARQL server, or external dataset resources. They can query, access everything in our data. Okay, so this is the method for producing link open data. And now another is why AI extension in extract data. Okay, this part is okay. Any question from this part? Okay, then now I will start the second part, use of AI extension. Actually, AI extension is not supported in this version. It's supported in upper version, OpenRefine 3.9.3. So I go to the higher version. I have a corpus dataset, a small corpus dataset that I will demonstrate on it. Okay. Browse.
Rajesh, we are already getting late. So
5 minutes. 5 minutes.
Okay.
This is a small demonstration.
Okay.
I have a corpus dataset including title, abstract, and citation. These are the bibliographic description in APS format. Okay. So when we enter this 3.9.3, we can see the AI extension. Okay. AI extension is available from OpenRefine site, and just follow the instruction for installation. And after the installation, we get the icon, this icon, AI extension. Okay. AI extension allows the several models of LLM, suppose, and as the API use of API, we can directly chat and get the result. Like abstract. Here is abstract. We can this abstract make in Bengali language. How can we do? Let extract using AI. Okay. Abstract, one column has to be created. Abstract Bengali provider, LLM provider. I have two provider, local Olama and OpenAI. How it would be configured, I will show you. Let's first try to use OpenAI, then the steps, and translate the abstract in Bengali language. NLP, just natural language. Okay, I put my file. Generate preview. Let's see. Response. You can see in Bengali language. See, we have translated the entire abstract in Bengali language. Okay. Another example, abstract in structure, JSON format. Okay. Extracting abstract JSON. OpenAI and response format JSON according to provided schema. I have written a schema, JSON abstract schema like this. From abstract, we want purpose, methodology, data, and result. We want these from the abstract. So we put here, and our query would like this. Generate a JSON containing the information in abstract mentioning the schema. Let's see the generate preview. We found the purpose, methodology. See, we purpose as abstract JSON column. See, just see purpose, methodology, data, and result. We extract from the abstract and write it as per our parameter. Okay, and this JSON format, we can use in any JSON supported database like non-SQL. Okay, and DSpace 7 DSpace version, we know that the DSpace version 7 onwards REST API backend database. If we could transform this from this JSON format and just put the copy paste on the REST API, and that will be reflected on DSpace repository. Okay, this is very easiest way from exchange, data exchange. Okay, JSON is popular for data exchange format. Now, how I do this? This is a configuration a path manage LLM provide. Okay. This OpenRefine has has been configured like this. Label OpenRefine, server URL OpenRefine version 1 v1 chat completion. This is the URL and model OpenRefine and in backend there are several models. GPT-4 0 mini, GPT-4 0, GPT-4 enterprise, several models, like L-Lama model. Okay, and this API keys should be generated before use of OpenAI. And this I have subscribed this API key. It is not free. I have subscribed. Okay, $5 subscribe. Then I got the API and put this. That's why we can extract from OpenAI. That is ChatGPT. Test service response the capital of Francis Paris. That means it runs okay. Then we extract for abstract in Bengali language, abstract in JSON-only format. Not only this textual transformation, textual manipulation, we use the other code level LLM like Cursor, like Codex, like Ground. Okay, this type of tool, and if we subscribe, then we can get their we can integrate in this AI extension. Okay, so this is the part of AI extension, and use of AI extension is number of huge large amount of data we can extract, we can manipulate, we transform in different way, not only in NLP also. Just put your language and machine will do, machine will everything like.
Thank you. Thank you, Dr. Rajesh. Hello.
Hello. Thank you.
Okay. Thank you
Jana?
for your nice presentation, rather hands-on training. So you are starting from LOD, semantic web, Web 3.0, 3.0 component, RDF, tuple, JSON, everything you covered here. And practically you nicely demonstrate how to download, how to install the OpenRefine and how to use the OpenRefine, rather how to reconcile data, say title or author or publisher from the external source like Open Library or VIAF, and ultimately it is very worthy that you ultimately build the RDF schema alignment and also download all these things in turtle format or RDF experiment format, and lastly you shown the AI extension and how to translate the abstract of the particular article or like that. So it is very helpful for the participant. I think all are very satisfied. If any question, please ask any question, or otherwise you can contact with Rajesh sir, so that he will give you all the technical information later on, because we are already getting late. Is there any question? Okay, thank you, Rajesh.
Thank you, Professor Jana sir.
Okay.
And thank you. I once again thank you, Professor Udan Bhattacharya, for giving me this opportunity.
Rajesh, can you stop your presentation?
Okay.
Please stop
Please
your
stop your
presentation.
presentation. Yes. Fine. And
माझे
we have some formalities.
Okay. Thank you.
Yes, sir. We have an announcement regarding our next study circle, which will be held on 30th May 2026. The session will be delivered by our esteemed speaker, Dr. Narayan Chandra Ghosh, librarian, IIM Joka, and will be presided over by our respected president, Dr. Shantanu Ganguly, Director of Library Services at Ashoka University. The program facilitator will be Ms. Joya Sharma, and the session will be anchored by Ms. Supriti Das. And now I hand over the session to Rupali for the formal vote of thanks. Thank you, all of you. Rupali?
Yes. Now we are at the formal vote of thanks. First, I would like to thank all the participants who have joined us for this session. I express my sincere gratitude to Professor Udayan Bhattacharya, the Director of Universal Briefing, for his constant and generous support. I extend a special note of thanks to the President of today's session, Professor Sibsankar Jana, for guiding this study circle so wonderfully. I also convey my deep appreciation to our esteemed speaker, Dr. Rajesh Das, for his excellent presentation. I would like to thank to the Joint Secretaries of Universal Briefing, Dr. Ranjan Samant and Dr. Sopan Khan, for their support. I also like to thank the Chairperson of Study Circle of Universal Briefing, Dr. Abhik Roy, the convener, Mr. Abhijit Noskar, and today program facilitator, Dr. Suparna Noskar, on behalf of the Universal Briefing Study Circle Committee. And last but not least, I thank all of you for giving us your valuable time. Thank you all. Good night. Thank you.
Okay. Good night.
Good night.
Okay.
Thank you all of
Good
you.
night.
Thank you, sir.
Thank you.
Yeah.